Welcome back. This is the next video for Unit 2 Analyzing Data. In the previous video, we discussed the SI base units, and in this video, I'm going to discuss some SI derived units. Derived units are determined from the SI base units. In chemistry, we commonly use two measurements that are derived from other SI units. Both of these were introduced in Unit 1. The first one is volume, and remember from Unit 1, it's a measure of how much space an object occupies. Volume can be measured in multiple ways. A liter, abbreviated capital L, is a typical unit for measuring volume. It's derived from the units for length, and it's typically in terms of centimeters, which is times 10 to the negative second meters. And we do it in the same way that we calculate volume in a math class. So we'll start off with this. This is a cube. All of the sides are supposed to be the same length. So we have a 10 centimeter side here, a 10 centimeter side here, and a 10 centimeter side here. The volume of this cube is length times width times height, or 10 times 10 times 10. 10 times 10 times 10 is 1,000, and our units here, so this is 10 centimeters, this is 10 centimeters, and this is 10 centimeters. The units are centimeters cubed. (1,000 cubic centimeters is 1 liter. Now, I don't think they just picked a box that had 10 centimeters on each side. It actually goes down to a smaller unit, and that's what we use here. Chemistry is typically in terms of milliliters, or 1/1000th of a liter. This abbreviation is lowercase m, capital L, and this means 1/1000th of a liter. And so if you imagine a smaller cube, let's make it about this size. It's a terrible cube, hold on. So a cube that is 1 centimeter on each side. The volume of this is 1 centimeter times 1 centimeter times 1 centimeter, length times width times height. And so the volume is 1 cubic centimeter. And a very important relationship in chemistry is that 1 cubic centimeter equals 1 milliliter. I even box that in. You only need that a lot. So this is volume. We took length and we made it in 3 dimensions to describe how much space an object occupies. The next one is density, and it's a measure of how much matter is in a given amount of space. Remember from Unit 1, this is mass per given volume. The units for density are given in grams per cubic centimeter, at least a lot of times in textbooks. And remember, a cubic centimeter is equal to 1 milliliter. And so interchangeably, we could use grams per cubic centimeter or grams per milliliter. These are essentially going to be the same thing. The only difference in the real world is that generally cubic centimeters deals with something that is a solid or something that is a gas, whereas milliliters could be something that's a liquid or something that's a gas. But we can use either one of these units interchangeably. Remember the definition of density. Density equals mass divided by the volume. If you were to make the volume of an object larger, let's say the mass stays the same size m's, but the volume was much larger. When you make the bottom number larger, you end up with a smaller number overall. So volume goes up, density goes down, if mass stayed the same. Looking at another one, let's say that volume stays the same, so same size V, but the mass is greatly increased. When you increase the top number, your overall value is going to increase. So mass is larger, density is greater. Volume is larger, density is smaller. That's going to be the general relationship here. A lot of the SI system is based on water. So the old temperature, or it's still in use, but not the scientific version, on the Celsius scale. The freezing point of water is how they determined 0 degrees Celsius. When the water outside started to freeze, they called it 0. The boiling point of water is determined by the 100 degree temperature, or 100 degrees Celsius. And in between any temperature between freezing and boiling of water, there are 100 divisions. For these to work, it needs to be 100% pure water. Something that we may talk about this year is that if you dissolve something in water, its properties are going to change. For instance, when it gets cold outside and they start throwing salt all over the roads, it lowers the freezing point of water, which means it will melt even if it's below freezing outside, and then it can drain off the road or the driveway, make it safe for the walker drive. 100% pure water has to work for it. Same for this relationship down here. 1 gram of water is 1 milliliter of water, which is 1 cubic centimeter of water. I'm going to write this over here. Pure water, 1 gram equals 1 milliliter. This is something that we use a lot as well. So 1 gram, 1 milliliter, 1 cubic centimeter. How about 1 kilogram of water? 1 kilogram of water is 1,000 grams. Kilo means 10 to the third. This is 10 to the third grams, 1,000. Remember that we're 1 gram equals 1 milliliter. That means that 1,000 grams equals 1,000 milliliters of water. In terms of liters, 1,000 milliliters is 1 liter of water, which we also determined was 1,000 cubic centimeters. And so you can see all these relationships based on water, and they are all based on powers of 10. You've got 10 to the 0, 10 to the third, 10 to the third, 10 to the 0, 10 to the third. It just makes it a lot nicer than the system that we're used to, which is numbers of 2, 8, 16, 32, 5,280. They're just a lot more tedious numbers. Everything here, being multiples of 10, is much easier to deal with.